Welcome to the course on Basic Electrical Engineering. In this video, I am going to solve one problem using Thevenin's theorem. This is the circuit shown in figure. Question is, using Thevenin's theorem, find the current in the ammeter shown in figure. Okay, this is the circuit diagram and this is your ammeter. Now, we have to find out what is the current shown by this ammeter using Thevenin's theorem. First of all, what is the Thevenin's theorem? What is the statement? Any complex circuit except the load is converted to a voltage source and a series resistor and is connected to a load. Now this entire circuit can be converted to a voltage source whose value is VThevenins and a series resistor and whose value is RThevenins. Okay. This represents what? Thevenin equivalent circuit. Voltage source and series resistor and is connected to a load. Let me name this load as RL. Okay, here our load is nothing but here ammeter. Now we have to find out what is the current shown by this ammeter using Thevenin's theorem. So there are two steps in this Thevenin's theorem. First we need to find out Thevenin's voltage and the second step is we need to find out RThevenins. Okay, let me find first Thevenin's voltage. The procedure is, so I will remove this ammeter and I will define VOC across these open terminals. Three volts, 2 ohms, 3 ohms, 2 volts. Now I removed ammeter and we have to define here VOC across these open terminals. Now we need to determine this VOC, means open circuit voltage. Here VOC is nothing but our VThevenins voltage. Now how to calculate this open circuit voltage? So what is the source value? 1 volt, 2 ohms. This is 1 volt, 2 ohms. Okay, now since it is open circuit, there is no current flowing in this branch. Let me indicate that through this branch no current is flowing. So I need to determine this open circuit voltage. Okay, let me first find out voltage across this 2 ohm. Then by using KVL, I can easily determine this open circuit voltage. Why? Because I know this voltage and this voltage, and we need to determine this open circuit voltage. I don't know the voltage drop across this 2 ohm resistor. So the first step is we need to determine this voltage drop. So for that, I consider this loop. This loop, we know that loop means it starts and terminates at the same node. Okay, let me define the current in this loop as I. Let me put positive, negative in the direction of current, indicating that current is flowing from high potential to low potential. Now let me apply KVL in this loop. By KVL, the voltage drop across 2 ohm is 2I minus 3 plus 1 plus 2I is equal to 0. So that implies 4I is equal to 2. That implies I is equal to 2 by 4, which is 1 by 2. That implies 0.5 amps. Now I know the current flowing in this 2 ohm resistor. So now the voltage drop across this 2 ohm resistor is 2 into 0.5. Let me indicate that voltage drop. I am indicating here the voltage drop across this 2 ohm resistor is 2 into 0.5, means it is 1 volt. So now I know the voltage drop across this 2 ohm resistor. Now I will apply KVL in this inner loop so that I will get VOC. Okay, let me calculate VOC now. I am considering inner loop here. The path of this loop is this one. Now in this inner loop, I am applying KVL. Again by KVL, voltage drop across this 2 ohm is 1 volt minus 3. See here, there is no current flowing through this 3 ohm resistor. Voltage drop across 3 ohm resistor is 0 volts. Now this battery voltage is 2 volts. I forgot to mention here, this is 2 volt. So 1 minus 3 minus 2. Here it is plus minus VOC. So plus VOC equal to 0. That implies VOC is equal to minus 5 plus 1 minus 4. That implies VOC is equal to 4 volts. Okay, this is the first step. We have to determine open circuit voltage. This is nothing but our VThevenin's voltage. So VThevenin's is equal to 4 volts. Okay, this is the step 1. Now what is the second step? The second step is we need to determine R Thevenins. So what I will do, I define R Thevenins across the open terminals and I will make this circuit inactive and I will determine this R Thevenins. So making the circuit inactive means you can make voltage source as short circuit, and if there is a current source, you can open that current source. If there is a current source, you can open circuit. See, now in this circuit we are having all voltage sources, so all voltage sources are short circuited. All voltage sources are short circuit, and I have to define R Thevenins across the open terminals. Now I have to determine R Thevenins. See here, this 2 ohm and 2 ohm are connected in parallel. So R Thevenins is equal to 2 into 2 by 2 plus 2. Now this parallel combination is in series with 3 ohm resistor. Now you have to add this 3 ohm resistor to the parallel combination. So if I calculate it, R Thevenins is equal to 4 ohms. Okay, this is the second step. So now I got my V Thevenins and R Thevenins. Now what is the final step? I have to convert this entire circuit into a Thevenin's equivalent and load. Here load is nothing but here our ammeter. V Thevenins, R Thevenins, and here load is nothing but ammeter. So here what is V Thevenins? V Thevenins is equal to 4 volts. Now what is R Thevenins? R Thevenins is equal to 4 ohms. Now, what is the current flowing through this ammeter? What is the current indicated by this ammeter? Simply current indicated by ammeter is V thevenins by R thevenins. So current shown by ammeter is 4 by 4, which is equal to 1 amp. Thank you.